We're just going to let the speakers introduce themselves so we can spend most of the time on the presentations and talk. So,
well, thank you very much for the introduction, ladies and gentlemen. I can't believe you. My name is Mehrdad Ehsani. I'm a young professor at Texas A&M University. I've been there about 38 years. Started life as a power electronics specialist, motor drives. That's a core enabling technology. Got me into aerospace power systems, electric and hybrid electric vehicles. I wrote about 19 books about these things. Some of them are international bestsellers. They make me about $900 a year, translated in many languages and so on and so forth. And of course, I'm interested in energy systems in general. A lot of my research with my graduate students is in this area. So necessarily, I paid attention to sustainable energy technologically. Then I began to realize that sustainable energy and renewable energy and global warming has a lot of emotional and ideological hooks attached to it that distorts the definition of the problem. And it becomes an opportunity space for people to sell their favorite technology rather than solve the problem in for its own value. So that's where I got interested in this. And basically, I thought it's a universal problem, but the planetary problem actually is extremely variable, so it has to be local solutions, local solutions for a universal problem. And so that led to the work I've done with the governments of Panama, Jordan, Saudi Arabia, Israel, and more recently with Ghana. We're just starting. So I'll give you an overview of what what my perspective is, and then some specific key technologies as points in case, or case in point. So is that good enough introduction?
That's perfect.
Okay, great. So I have lots of slides, and I've been told that I'm going to be given proper warning, and if I exceed my time, the trapdoors will open and I will fall into the snake pit. Energy, it is really the fluid of technological advancement and civilization from the 19th century, the production of coal, industrial revolution, and then oil and so on and so forth. So if you have energy, you have the wherewithal to develop economically, technologically, and so on and so forth. Now, about 30, 40 years ago, there was this idea of peak oil and all that stuff, and that became an urgent thing to go to alternative energy. And I'll show you that, of course, we all know it, but I'll show you some factual numbers that's really a bogus assumption. There's plenty of hydrocarbon energy, so that's not going to be a motivation to go to renewables or sustainables. But then we have this idea of global warming. And that is, although true and real, and I can give you personal examples in Texas where my beach home was blown away with a hurricane that is a result of this. And over the past 20 years, the water in front of my house has risen 2 feet. Never goes down. It's just very real. I see this. But the idea is to define this problem, at least to the best of my intelligence, in a sincere, intelligent way, however difficult it is to solve it. If you don't define the problem correctly, your solutions are trivial and intellectual. I have to use a clean word, recursive nonsense. So starting with some facts and data, world population in my lifetime has tripled, and I guess that means I'm kind of old. And it's going to taper off somewhere around 9.2 billion people by the mid-century here. So the population of the world is increasing, at least by another, 20, 50%. Still, most of the energy consumption in the world is hydrocarbon-based, whether it's coal, natural gas, or they're all carbon-based. Very little penetration by the clean technologies from nuclear to all the other ones. And of course, this 76% hydrocarbon is responsible for the greenhouse gases, most of which are CO2. We know that. And a little bit of it is due to environmental damage, deforestation, the reaction to economic impoverishment. I was in the country of Ecuador many years ago. I was very happy to go there. I thought it was an equatorial type of a country. I was going to see the Amazon forest or all barren hills. It was desert. So what happened to the jungle? They had to raise it to make wood for economic development. So there's a lot of environmental deforestation and damage that goes on. So here are some numbers that kind of put it in perspective. There's, by some estimates, about 500 exajoules of hydrocarbon resource accessible to our technology in the world. At the rate of human consumption of 0.5 exajoules, at the present rate of consumption, which is just an indicator, we have about 1,000 years of hydrocarbon fuels accessible economically. And somebody said, I don't know if you know who it is, that Stone Age did not end because we ran out of stones. So we're not going to evolve out of carbon-based energy economy because we're going to run out of hydrocarbon fuels. In fact, if you look at one variety of hydrocarbon fuel, namely the methane hydrates, these resources are distributed around the tectonic plates in a very equitable way all around the world. So we have access to enormous amount of natural gas with technology which is not difficult at all. Coming to uranium, which was one of the subjects of keynote speeches yesterday morning, we have about 9,000 years of uranium available to us. Now, I used to give talks about we have 40 years of uranium. That's 40 years of cheap uranium. But when it comes to expensive uranium, more difficult to refine, we have a lot of it. Now, the difference between cheap and expensive may be a factor of 10. But when you realize that 1 kilowatt hour of electricity from nuclear power has a contribution of 0.2 cents from the uranium fuel, if this fuel grows by a factor of 10, that 2 cents to 1 kilowatt hour, it's not going to stop us. So plenty of even clean nuclear fuel. In this country, it's really remarkable. In the 70s, there used to be this fright of oil shortage and strategic reserves for military purposes. We used to actually buy oil and put it in salt mines. So now we have not only 300 years of coal, 120 years of natural gas with the new technology of fracking, 300 years of unconventional liquid oil in North America, including Canada. And this is very interesting. The U.S. is the largest producer of oil and natural gas in the world. And more importantly, a country as sophisticated, as rich as ours, when we found it to be expedient and profitable, we are exporters of hydrocarbon fuels. So rich people find it profitable to politically and economically change things so that we export oil. That tells a lot about Saudi Arabia and Russia and Iraq and Iran. These countries depend on this for their livelihood. That's the only source of economic development they have. We have all this multifaceted economic potential, and we still sell oil and natural gas. So this is very important. I'll come back to that because the whole idea is to define the problem with the right perspective of socioeconomic constraints. So obviously, hydrocarbon shortage is not at all a motivation for sustainable fuel. And here's kind of the beginning of some of the things I want to convey to you. The United States and Europe together constitute about 10% of the world population at most. 90% of the world population is not nearly as developed as the, what is it called, OECD countries, the developing countries, Europe and America. 90% of the world population is aspiring to reach a minimum of acceptable 21st century standard of living. Many of them are concentrated in China and India, but also in Latin America and Africa and the rest of Asia. So when you look at the potential greenhouse emissions in the next, 30 years, estimated by some sources, the total contribution from present, say, 35 to 100 is done by the developing and emerging world, the 90%. The developed world, US and Europe, is here. Their expected emissions and their improvement in curtailing emissions. If we really are serious about global warming and environmental catastrophe, which we should be, and we're sitting here, is this the problem to solve or is this the problem to solve? Duh, it's very obvious. You don't solve the 10% problem, you solve the 90% problem. The question is, what is the 90% problem and what are the outlines of an approach to solution? Put another way, cleaning the United States economy in terms of transportation and industry, or Europe completely, does not make a major contribution to the reduction of greenhouse gases and recovery of the environment in terms of greenhouse effect. I can go through these data about, there's a reason why renewable energy, clean energy, sustainable energy is not penetrating. And the effects and the reduction in CO2 is very limited. And political agreements between haves on behalf of have-nots have produced nothing but just showcasing. And no technological or effective strategy or results have come from it. Give you an example. If the United States and Europe tomorrow come up with this razzle-dazzle technology and use zero hydrocarbon fuels, zero oil, without damage to their industry, what do you think will happen to that oil? Remember, oil is produced by the producers at around $5 a barrel. It's a secret, but it's not a very difficult secret to figure out. $5. So the cost of production of oil is $5 a barrel. What would Saudi Arabia do? What would Iran do? What would Russia do? What would the United States do with surplus unused oil? They will come up with economic incentives for the 90% of the world population who's desperate to get out of the 17th century, go through the 18th century industrial revolution quickly and catch up with the 20th century technologically, socially, economically. They can do that. They can do that with a very well-known business model, which is used by Hewlett-Packard printers and by the old Kodak film company. You know, when they used to give away the camera so that you buy the film. So I can think of this. If I can think of it, I can think of it much better. An oil producer like Saudi Arabia would go to Africa, to India, to anywhere, and build oil-based power plants for free and get paid from the revenues of that power plant over the life of the power plant for the fuel that they're guaranteed to sell them. So you sell them the camera, you give them the camera for free, you charge them for the film. You give away the printer, charge them for the toner. So that's the thing. So the point is, oil is a fungible commodity. It's like gold. Gold never goes on sale anywhere in the world. It's the standard of value. Oil is that way. If we don't use it, somebody else will. The demand is huge, 90% of the world population, and the supply is extremely resourceful, aggressive, and low cost. Getting the United States or Europe into zero carbon emission, taxing carbon, I'm sorry, this sounds like fairy tale to me. You can tax developed people with a social and political and legal order that can be reinforced. We're not going to tax the 90% of the developing world without that kind of a structure, legal structure, to pay a price for carbon emissions. So this idea of, I've got a great technological solution, We heard a lot of it yesterday during the keynotes. Only if people don't dig holes in the ground. This only if negates all the brilliance of their, I mean, the solution should fit the problem. The old saying is, if all you have is a hammer, then all problems in the world look like a nail to you. But that's not the problems are much more sophisticated than that. Okay, so the definition of the problem is ill-defined. So what do you do? Really, the fundamental thing is you have to treat the environmental catastrophe that is emerging as an epidemic problem, the same way that we have treated the medical epidemic problems. When you want to eradicate smallpox or polio, you don't just make the rich people healthy and immunize the rich people so that they don't get sick. You immunize the poorest person, the furthest away from access to medical treatment. You immunize them because it's a global problem, because virus has no boundaries. The atmosphere has no boundaries. The planet Earth has no boundaries in terms of environmental greenhouse catastrophe. So we have to look at it as an epidemic problem and solve it at that level. With that definition, what is the technological solution to the problem? It turns out not to be razzle-dazzle, new discovery with new materials and new, and we're all good at that. I've got my corner of that universe as well. So the developed world, the 10%, should come up with economic and technological solutions that the 90% of the world population that is on the rise, inevitably, especially with the surplus of oil, they will actually opt out for that rather than oil-based energy economy. It's a challenge. How do you compete with $5 a barrel oil and the economic incentives that the producers of that, including the United States, will give to the developing world? How do we do that? We can do that. Along the lines of the way the American Marshall Plan revived Europe after World War II, after that catastrophe, we enabled that, ostensibly out of altruism, but in fact for very good, sensible economic and political benefit. So you have to solve the problem globally. You have to pay attention to the 90% that are the real threat for emissions, not the 10% who can easily clean themselves up because they have the technological and economic wherewithal to do it. That means appropriate technology, understand the local problem physically, socially, and economically. And so local solutions for local problems for a global outcome type of a thing. And do it not as a top-down dictatorial system because it doesn't work, but with market economy, good business models, and with a profit motive. If the United States can profitably sell fried chicken and hamburgers in China and Japan, we can certainly sell good technological solutions for advancement of the developing world in a faster pace than they themselves can do with the help of the oil producers. We can develop them faster with appropriate technology. That kind of a marketing capability, technological know-how, local participation, and so on. Give you a couple of examples of some of the countries that we actually have worked with. We managed to understand and convince part of the people that convinced Saudi Arabia government that solar energy is very appropriate for Saudi Arabia. If we can sell renewable energy to Saudi Arabia, we're good at local solutions for local problems. Here's the line over there. They produce oil. That's their main source of revenue. They produce it at roughly $5 a barrel, sell it at between $60 to $150 a barrel, depending, in a good day or a bad day. And they use a significant portion of their oil production for local electric power. And 40% or 60% of their electric power is used for desalination of salt water for their water consumption. a very unique, fantastic opportunity. Desalination does not have to be done with reliable electric power. It can be done with intermittent electric power, like solar power, photovoltaics, maybe wind power. And you don't do energy storage, and all the technological complications of batteries and electrochemical, whatever energy storage. You do value storage. You store the product. In this case, water. Water stores very well. It's very efficient and low cost to store. And so when electricity is available, you make water. When it's not available, you use water. And so you can meet a variable, unpredictable demand for water from an unpredictable electrical source that doesn't track the demand, unlike conventional utility grid, because of this unique problem. They have the capability and the need for water storage. Now, why get them off oil and into solar energy? Because instead of burning $5 a barrel, I use that number as a typical example. Instead of using $5 a barrel oil, they can sell that oil for $60. Whatever they don't use, they sell. So it's profitable for them to go sustainable, and so on and so forth. There are many other examples. Let me now switch gear and talk to you about another myth about clean vehicles, zero-emission vehicles. I'll go through this very fast. It turns out that there is a reason why conventional hydrocarbon vehicles are so successful and so satisfying to the markets. There are fundamental reasons as well as technological and historical reasons. The fundamental reason is that conventional vehicles carry liquid hydrocarbon fuel, which is easily tankable, very dense in power, in energy, and they only carry the fuel, not the oxidant. They are immersed in half of the fuel, which is the oxygen. So it's a very efficient way of carrying energy with you in a mobile sense. That's why aircraft use liquid fuel and cars use liquid fuel. It turns out that the hydrocarbon internal combustion engine will fundamentally be more appropriate for transportation than chemical battery of any kind that we know of, and electric motor or hydrogen fuel cell. And so I don't have time to go through these things. If this really shocks you, we can, during the Q&A, open this or peel this onion layer by layer. So you see, these are not difficult concepts to verify. So here is, for example, what we know about the various onboard energy storage systems. The electrochemical batteries, here's the current favorite lithium-ion battery in terms of energy density in weight and volume. The number is approximately 100. Compare that to hydrocarbon fuels, a factor of 100, 2 orders of magnitude in weight and volume. That's what the electric vehicle has to overcome. Now, the other thing is, of course, the speed of charge and discharge. In a conventional vehicle, you discharge the tank over many, many hours, like 6, 7, 8 hours, and you charge it over a few minutes at a rate of 4 megawatts when you put the fuel in the tank. That kind of a charging of a battery is not only a local problem with the electrical grid and electrical system. Fundamentally, the conventional batteries that we know, conventional batteries, not the liquid, whatever it is, boron type exchange, that's a different issue with different problems. Batteries always take longer to charge than discharge. There's a fundamental discrepancy. We'll get to these things. But you see, of course, electric motors are the most appropriate traction power plant for automobiles compared to internal combustion engines. And their efficiency is at least 4 times as good as internal combustion engines. But this 4 times improvement on the power plant discounts the density discrepancy of the storage by a factor of, so now our power plant is 4% as dense as a conventional hydrocarbon fuel plus internal combustion engine. We have a factor of 25 to overcome, and there's not a whole lot of magic bullets left to overcome that. What does that mean? This is about all the statistics about the adoption of electric vehicles around the world. The point is this: electric vehicles are specialty vehicles. They have unique advantages and characteristics. They will not displace conventional vehicles. Fundamentally, there are two things electric vehicles do well. They're high performance. They make great sports cars. I think all sports cars, two-seaters, Porsche, they should be electric because it gives you extremely adaptive, wonderful acceleration. And they have short range inherently because of the issues we talked about and many other issues having to do with environment, temperature, this, that, the other. Well, how can we take best advantage of these two limitations? Well, in the West, high-performance electric vehicles, perfectly okay. Luxury vehicles for enthusiasts. For the 90% of the world population, electric vehicles that give you less than 100 kilometers per charge, use lead-acid batteries and good old DC motors, or something more advanced like brushless DC motors, switch reluctance motors, the technology I developed over 20 years. Very appropriate for traction. 4-passenger car for about $2,000. A $2,000 electric vehicle for India would actually have an impact on the 90% adopting this versus a hydrocarbon-based rickshaw that they use in India or whatever. So I have to fast forward very quickly. Very quickly, I can show that the fuel-to-wheel efficiency of electric vehicle is only about 27%, with very optimistic efficiencies of the power plant, transmission, energy storage, and so on. That can easily be overcome by conventional hybrid electric vehicles. Something else, let's see. Case studies of countries actually using electric vehicles because all of their electric power comes from hydropower and so on and so forth. I don't have time, unfortunately, to talk about those things. I will mention to you that the technology of hybrid electric vehicles, and I was a contributor to the International Confusion with my first book on this topic about 20 years ago, has gone for this design philosophy. Use the internal combustion engine for average loading and use the battery electric motor for peak loading. That results in a very large electrical system, a very small combustion engine. It increases the price, and if you run out of charge, which you invariably can abuse the drive cycle to do that, you end up with a lousy car at a higher price. The better philosophy is use a full-size conventional engine and make it as efficient as possible with an incremental cost increase. And that results, again, I have to go very fast. You can show that with about 25 kilowatts of electrification of a conventional car, you can get most of the benefits of hybridization, miles per gallon versus in a given drive cycle for different size cars. So, and there's a fundamental reason for that. I don't have time to talk about that. And it turns out a 25 kilowatt electrification of a conventional vehicle covers all the operational points in acceleration and deceleration of any size vehicle in any drive cycle. So hybrid electric vehicles as a case in point, pointing as an example for the developing world. In the developing world, the thing to do, these 20% of world population, in fact, which dominates the emissions right now, efficiency improvement. Efficiency. We can easily improve the efficiency of our industrial energy consumption and vehicle consumption by 30%, easily, technologically. That's a quick fix for reducing emissions. Then let's pay attention to the 90%, appropriate technologies, appropriate business models to actually get in there and develop an African village with renewable energy connected with electric vehicle, which is used as an energy storage for solar energy, and so on and so forth. All these technologies that we've done before they are sold if hydrocarbon-based central power plant, and do it in an islanded way, which eventually becomes connected together as a national grid. We can do that, but it takes a different way of thinking. It's thinking, if you love Mother Earth and its atmosphere, you have to transfer that love to the inhabitants. And it's not my atmosphere, it's everybody's atmosphere type of a thing. It turns out that this solution of efficient hybrid vehicles with 25 kilowatts has an incremental cost of about $7,000, which pays back in 45,000 miles, rather than the conventional Prius, which is one of the most successful hybrid vehicles, that has a payback 118,000 miles at some fuel price assumption. That's beyond the point of an operator's interest. So, bottom line, making electrical transportation in the United States emission-free is a trivial exercise, because if all of American transportation, land transportation, became emission-free immediately today, its impact on the global warming after 50 years is 1/40th of 1 degree Celsius. That is not a significant problem to solve. The problem to solve is to get the 90% into emission-free transportation, appropriate electric vehicles, and so on and so forth. And inexpensive electric vehicles, less than 100 miles per charge, is well adopted by the rest of the world. Again, these are kind of patches. Where does electricity come from? We don't have time to talk about that. Sustainable distributed microgrids. I guess we can more or less stop there. So, thank you.
Great, thank you. So it looks like we have 3 or 4 minutes for questions. Go ahead, yes, sir.
Thank you for the great talk. I have a question about the definition of problem. Actually, your definition from problem is really illustrating for academic people, but don't you think that this definition gives extra excuse for governments like current administration to continue working on like coal power plants, because they say it's only 10% of emission and it's not big enough?
I hadn't thought about it that way. Of course, any good idea can be subverted. We have 2,000 years of experience with that, with somebody in Bethlehem did something nice, and you know, all those things. And so every good idea can be subverted to bad intentions. But no, the idea is the developing world can become more efficient and become less emitting. But the most important thing is for the developed world to aggressively develop the underdeveloped world appropriately. So I'm not, the part that I'm incompetent in is politics. Politics is a game that is above my pay grade. You're absolutely right. Anything can be subverted. Let me put it this way. If somebody uses my suggestion and wants to go back to coal oil electricity production, I accept that, as long as they do the rest of my prescription too. That get the 90% of the world to do it right. So.
Yeah, so if you could maybe go back to that chart that you had with the 90 and the 10. I think there's a bit of a number mix-up.
I'm sure.
I mean, or you don't have to, but what you made
conveniently, this has frozen up, so I can't do that.
Yeah, that's fine. So you said that pretty much the developed countries account for 10% of
That's an approximation.
So that's not, I mean, if I look at the numbers by other sources, it's more like 33%. So the US alone has 15%. So if you factor in the European.
How many people in the US, you think?
Huh?
How many people are in the US?
330 million.
330. How many people in Europe? So I took it as, say, 400. So that's a total of 750 million, which is 10% of 7 billion.
Yeah, so if you talk about, of course, but that their per capita, I mean, if you look at,
Oh, their economic impact is gigantic. Absolutely. It's not.
But population and greenhouse gas emissions obviously are two very different things, right?
Yes.
And I think that chart was referring to not population numbers, but it was referring to greenhouse gas emissions.
Oh, the chart of future emissions, you mean?
Yes. So, and you said that the 10%, it is true that 10% of the world population are in these kind of developed countries, but the greenhouse gas emissions, of course, per capita is much higher.
Correct.
So the problem that I have with, like, I like the way that you are kind of, trying to cut the problem in a way that you target it towards where the action really has to happen, where the growth is. My problem with that is that boundary of developed and developing is extremely blurred. This is not a dichotomy, right? We
Absolutely.
have 200 different countries. But if you do it like that, you can almost group countries in whatever bucket,
Yeah.
and by that give them an out to say, oh, we're just the small kind of problem. The other guys are
Yeah.
the big one. And it's true. Like in Africa, these people, I've still spoken to governments in Africa. They say, oh yeah, it's the industrial countries. Now we have this. So you end up in this
Yeah.
problem where.
Right.
So I guess my question is, how can you use this to actually be actionable?
Well, absolutely. Remember, this could be a book and a lifetime of me walking with the book and presenting it. This is a cartoon version of a much more sophisticated, complex issue, some of the complexities you two brought up. Absolutely. I didn't portray the entire problem and the entire solution. I'm just giving kind of a keyhole view of a new perspective on this thing. You're absolutely right. There are many flaws about this. There is no demarcation and definition of developing this. That it's a philosophical shift. If there's one outtake is let's treat global warming the way we treat medical epidemics. You absolutely cover the entire globe with your resources, but with local adaptation, whatever that is, rich, poor, and so on and so forth. It's the idea of getting there and develop the have-not before the surplus oil gets to them.
All right, we got to